parameters, they are basically pass band ripple, stop band ripple component, and the frequency components, pass band frequency, stop band frequency. These are the parameters we need to take from the user, and then we have to use the comments like, or we can say that the function like ORT to return the order of the filter. Then butter is the function that will basically implement the filter. So first, so let's write some program. So CLC clear all, close all, then format, okay, then so these are the basic formalities we have to program. Then we need to take the parameters such as pass band ripple and stop band ripple from the user. So let's RT is the pass band ripple component, and we want to take from the user. That's why the input is the command by which we can ask uh, the user to enter these values, and this value will be directly assigned to RP. So in enter passband ripple. So we are asking user the passband ripple. Then similarly we will ask from the user stop band ripple. Then we will ask the passband frequency. WP is the passband frequency. Then we will ask stop band frequency. Stop band frequency, and then sampling frequency. These are the parameters we need to collect from the user. Then these are the input we need to this is the algorithm that is used are used with normalized value. So whatever the parameters we are taking from the user, we need to normalize first. So the passband frequency normalization can be done by W1 is the normalized frequency of passband according to the formula. It is twice WP by sampling frequency Fs. So this is a normalization for the passband. And next, for the stop band, same thing we will do. So this is the passband and this is the stop band. Then the parameters we have collected from the user. Next, we have to, according to the procedure, we need to write the program. So we will use the function called butterword, butterword. So this is the function. That function will return the order of the filter and the cutoff frequency of the filter. And the parameters it needs is passband ripple, passband frequency, stop band frequency, and passband ripple, and stop band ripple. Is of analog in nature. That's what the is in quotes stands for the filter is analog. So therefore, it is basically that transfer function will be defined in Laplace transformation form. So this function will return the value order of the filter and the cutoff frequency W. Then we will use another function called butter, butter. That function will be basically implement the filter, the actual filter. So, and the parameter will take as an argument the order of the filter, then the cutoff frequency, successful filter is high pass filter. Is high pass filter that as a result of filter, the AC will be this function will be done numerator position and numerator position of our transformation. That is easy. So we will do the transfer function. Then this transfer function coefficient we need to pass some input. So equals we need to pass is 0 to pi. So interval is 0 to 0.1. This is the step size. So there is a function called a pick is return the response of the filter. So pick is we are passing the transfer function b comma a and the input w. So this is the program. This is the small program we have. Now we are saving the code. So let's run the code. So the passband repeat it is asking. So I'm giving the value 0.2 is a passband ripple and stop band ripple I'm giving 40. We need to know that passband ripple will be always small, so that that's why the stop band activation will be much higher than the passband. Then the passband frequency, suppose I'm entering 2000 and the stop band I'm entering 45,000 and sampling frequency is 8,000 given. So let's A0 x2 undefined x2. Okay. So this will be W2. That's not even. So again I'm giving the ripple 0.2. Then T is the passband ripple. Sorry, stop band ripple. 2000 suppose the passband frequency. Stop band frequency is 3500 and so let's see what is it also the frequency response. So frequency response we are getting is this is the frequency response as it is a high pass filter. The frequency response will be like this. So high frequency components will be allowed by the filter. So the transfer function is like this. So I'm sharing you the code. So please you go through and you run yourself and tell me the whether you can able to do it or not. So here. If, so please look at chat box. Yes. And অন্য আর সবার রেসপন্স একটু আসলে এক এক করে জিজ্ঞাসা করছি। আগ্নেয় তোমার এসেছে? আচ্ছা, ঠিক আছে। আনসু? Anshu is not audible. So, Olukriti, you got the output? December? Divanshu?
হ্যাঁ স্যার পেলাম।
আচ্ছা, দিগন্ত? আউটপুট এসেছে দিগন্ত? আচ্ছা না,
বলছি আমার মোবাইল দিয়ে কানেক্ট আছে, তাই পরে করে নেবো।
আচ্ছা আচ্ছা, ঠিক আছে। তো এই তো দেখো তাহলে দিগন্ত কিছু দিতে। Yes, sir. That's ঠিক আছে দিগন্ত, thank you. So we are going to our next program. So this is a high pass filter. So next program we will write program for band pass filter. So So band pass filter, the same code I have copied here because the most of the steps are same. So we need to collect the frequency components, ripple components, frequency parameters and ripple components, sampling frequency, and the process of normalization is same. We need to collect the order of the filter. So that up to that it is said. There is a small modifications are there. So what is the small modification after what word? In band pass, band stop or band pass filter, what happens there are two pass bands. So upper pass band, lower pass band, and upper stop band, lower stop band in case of. So in bands pass, basically it will pass some band of the frequency, and in band stop it will pass it will stop some bands of the frequency. So in case of band pass filter, the first frequency is called upper cutoff frequency, and the next frequency is called lower cutoff frequency for both of them. So here the basically the cutoff frequency is not a single value in case of low pass filter or high pass filter. So it will be a array. So W1, W2. So W1, W2 means the cutoff frequency will be two values are there. That's why I am keeping these two value in an array. So W1, W2 is the upper cutoff frequency and lower cutoff. This is the and then we need to pass this WA into RTP